Hello, Ben here. Um, Today we're going to do some Elm. Specifically, we're going to implement or try to implement one of the games from Computer Space Games. This is a 1982 book that I remember fondly. These books were published by Usborne in the UK, and they contain little basic games that you could type into your 1982 computers and play. The one we're going to implement today in Elm is Starship Takeoff. You are a starship captain. You have crashed your ship on a strange planet and must take off again quickly in the alien ship you have captured. The ship's computer tells you the gravity on the planet. You must guess the force required for a successful takeoff. If you guess too low, the ship will not lift off the ground. If you guess too high, the ship's failsafe mechanism comes into operation to prevent it being burnt up. If you are still on the planet after 10 tries, the aliens will capture you. That sounds bad. Quite exciting. Let's have a look at the program. So it's 19 lines of basic. And there's a bunch of stuff here to make it work on the variants of basic that they had on different machines back then. But we can just look at the main code up here. So it starts off, it clears the screen, prints Starship Takeoff. Looks like it selects two random numbers, one from 1 to 20, one from 1 to 40. Puts those in variables G and W, which I guess is gravity and weight. We multiply those together to get a number called R, which I guess stands for right, maybe. Print what the gravity is. We ask the user for a number, then we go into this loop here. We go around the loop 10 times. If we fall out, we get you failed, the aliens got you. Each time around the loop, we give you some feedback on your answer. If your answer was correct, we jump to the win state, which is here at 990. Good takeoff. So, looking at this, we've got some random numbers being generated. We've got a loop, and we've got two exit states. You failed, the aliens got you, or you made a good takeoff. Let's see. Let's get this going in Elm. I think I'm going to ignore the random numbers for now, and we'll start off with trying to implement the loop. Yep. So I'm doing some stuff in Eliap. Eliap is an app where you can write Elm on the left here, compile it and run it on the right here. So it's quite useful for playing with Elm or trying things out. I've got the most basic Elm program, I think, here. So we're using, for the main function, we're using the browser sandbox. That requires us to define three functions: an initial model, a view function, and an update function. Let's have a quick look at those. The initial model returns a model, which in our case, we've just got a blank model at the minute. We'll be putting all our world state into that. Our update takes a message and a model and returns a new model. So you get a message in from the app, maybe someone clicks a button or does something. A message comes in, you look at the current model, handle that message and return a new model with something changed. Our view takes a model and returns some HTML. So currently we have our view just returning an H1 with the text Starship Takeoff, and when we compile and run the program, which I can do by clicking here, you see Starship Takeoff over there. So let's get started. Let's have a think. So I think we want, like we said, we saw 3 states. There was sort of a countdown. The game was in 3 different states. You were making guesses. You took off, or the aliens captured you. So maybe that's the first place to start. So let's say our model is a type, and we'll use a sum type here. And the 3 type constructors will be where we're guessing. We could just call that playing. Let's leave it at guessing for now. Or we took off, or we were captured. Yeah. And I'm just going to press this button up here to format things. So there we go. Now there's not enough in that state to there's not enough in that state to represent the game. We also need to represent the 2 numbers, the gravity and the weight, I think. So let's do that. So I'm using my Vim shortcuts, which won't work. So let's create a I think let's call it world. This might not be we might change that naming later. So the world has some gravity, which is an integer, and the world has spaceship weight, which is also an integer. Yeah, that's good. So now our guessing takes a world. Our guessing carries with it a world. So let's make our initial model. So our initial model is guessing, and let's just remember in the basic program these were randomly generated. And let's just see if that compiles. Oh, something went wrong because I've used a colon semicolon. There we go, so that compiles. So I think we can now say text, and now say gravity, gravity now gravity is an int. We need to turn it into a string. String from int model. So we only have this when the model is in the guessing state. So yeah, let's ignore that for a second. Let's do something else first. Let's say case model of takeoff. So if we're in the takeoff state, which we can't get to at the minute, but we want to say, we'll return a div which has some text. You got away. Now, if we're in the captured state, we want to give some text. Oh no, the aliens got you. But normally we'll be in the guessing state and we'll have a world. Maybe we want to show the title every time. Oh well, let's ignore that for the minute. Yeah, we'll ignore that. We'll get it working and maybe we'll tidy it up afterwards. So, we want to show gravity string from int world.gravity. I think this is going to complain because we need some. Oh, we need another thing in here. Something went wrong. Let's have a look. So, alright, so we've, yeah. Can't find guessing state because we've just got it guessing. Right. So now we've got some precedence stuff going on. And we can, for now, we can just solve this with brackets. Okay. There we go, priority 5. And let's say if that was 6, just to check. There we go. Gravity is 6. Great so far. Now, what do we do next? So I guess now we want to we want a message coming in that says, here's my guess, right? Or we could do the number of characters. Right, I'll tell you what we can do. We're going to add a guess to this. Our guess is just going to be an integer at the minute. Actually, it's going to be a maybe hint, because when we first start, we haven't made a guess, so that's nothing. Okay. Now we need a couple of messages, I think. We're going to have a input field on the page and an on change handler connected to that, which updates the current guess, and then we'll have a button which has a check guess on it. I guess this is one of the confusing things about Elm, if you're used to the idea of there being a form and a submission of the form and all the data coming in at once, that's not really the model that Elm works to. If we have a field on the page, we need to record the contents of that field in our state somewhere. And let me show you. So I think we're going to have an update guess, which is probably going to return the guess as a string. And we'll have a check guess message. This should also compile, I think. Oh, guessing world. Oh yeah. So we've added the guess to that. So there we go. It's still compiling. So let's add an input to this. Type is number. I think we can do that. On change, I think we can do that. On change update guess. Let's see how that looks. Can't find a type variable. So attributes come from HTML attributes. Okay. It's not on change. Good thing is I have the Elm documentation here. I should know this. And I guess it's on input. Okay. Let's give that a go. Now we've got input in there. Great. And we'll have a second input, which is a button on click. Let's check guess. Oh, no. It's not a very exciting button, is it? Launch. Or maybe I'll just put it in here. There we go. We'll just click this to format our stuff a bit neater. Okay, so now we can click launch. It's not doing anything. And that's because the thing that receives these messages is the update function. So what have we got to do? Well, case model of if took off, we just want to turn the model. If we're captured, we just want to turn the model. There's no updating happening once we're taking off. But if we're guessing, to handle the different. So case message of, and it can be update guess, at which point we want to return. We're still guessing. We haven't changed the world, but we are going to change this to something. So we're going to do we are going to change the guess to string to int. And that returns a maybe. That returns a maybe string, maybe int. So we should be good with that. If we're going to check guess, we still need to do that. So let's compile it again. I don't think we're going to use that anyway. We don't care about the current guess. I'm updating it right now. Right, so now we think our model is being updated. Yeah, you can see those messages coming in here. Okay, this is going well. So now we need to do something when we check the guess. And now we do need this thing here. And I'm going to say if, let's make a function, event a function check. It's going to take in our world and our guess. In fact, let's so if it's too high, just want to turn the model right now. Just right. At this point, we want to return takeoff. Right. And we need to define this function check. And it looks like I'm passing in a world and a guess. Do I want to pass in that? Let's define guess results too high. In case you're wondering where those things came from, they didn't exist yet. And that's going to return a guess results. Now our guess is a maybe int. So what do we return in this case? So we're going to say let force equal world.gravity times world.spaceship weight. If it is greater than force, then too high. Else, if int is less than force, then too low. Else, just right. And now when we compile it, I suspect it's going to say, oh, yes. This case is not our branch because when we were implementing that, we implemented this R. Right. So compile that. Okay, we've got a thing now. So we set the spaceship rate to 4 and the gravity to 6. So let's try 20. Didn't work. 28. 24. We got away. So we're doing something right. Although it's getting a little bit. It's already quite a lot bigger than the basic program. So let's just format that. It's got bigger again. Okay. So we're getting somewhere now. Maybe our world should have a message. So we can say too high, too low. So our model here. So we're going to make another type message, feedback message, and that's going to be maybe a string. And we've got nothing when we start out. Okay, now it's saying message. Oh, same here. Well, it's compiling, but it's not much use. Let's put our message in here. Text maybe dot with default message. And again, we're going to put brackets around that to ensure that this all works. So now when we do 20, okay. So here, so here we want to return a guessing. World hasn't changed. Our guess hasn't changed. Our message is going to be huh? Yeah. It's a similar thing here. Similar thing here. Too high. And here, too low. 20, too low. 21, too low. 25, too high. 24, you got away. Excellent. So what have we got left to implement? We have to, and we could start tidying this up now. There's a bunch of duplication. It's a bit wordy in places. There's a lot of nesting, which we can get rid of. But let's take a little break.